Good day everyone. Today in this session, we will discuss scalars and vectors. In our video in measurement, we talked about quantities that we measure and how they are expressed. But how are these quantities described? Is it enough to describe the quantity with the number and the unit? Or the quantity requires both magnitude and direction to describe completely. After describing the quantities, the discussion will focus on vectors, how vectors are illustrated, and how vectors are done graphically. Can we add vectors? If so, how is this done? What do you call the vector output of combining vectors? Length like 50 centimeters, a mass of 75 grams, a volume of 20 liters, and the density of 1.27 grams per cubic centimeters are described with the number and the unit only. These are magnitudes of the quantity. Quantities described by a magnitude only are called scalars. Quantities that are entirely described by both magnitude and direction are classified as vectors. Examples of vectors are displacement, 5 kilometers north. Velocity, sample measure is 20 meters per second upstream. Acceleration, sample measure is 2.5 meters per second squared to the right. And force, sample measure is 75 newtons, 120 degrees. In naming a vector quantity, a capital letter with an arrow can be used. Like vector A is 120 meters, 40 degrees north of east. Other ways of naming vectors are by italicized small letter and the known symbol for the quantity. Examples are V for velocity with a measure of 15 meters per second, 20 degrees. A for an acceleration of 9.8 meters per second squared down. F sub F for frictional force, T sub 1 for tension 1. In any given vector, say vector A, the vector's magnitude is A and the direction of the vector is theta sub A. For example, vector A equals 120 meters 40 degrees north of east. The magnitude of the vector A is equal to 120 meters. And the direction theta sub A is 40 degrees north of east. Now, how important is the direction for a body in motion? A man initially at point O walked 50 meters. Where is the man after walking 50 meters? Is he at point A, at point B, at point C, at point D, or at point E? Any of these points can be the possible location of the man after walking 50 meters. So to be specific with the man's place after walking 50 meters, the direction must be specified. So if the man walked 50 meters towards the south, where is the man after performing the motion? Among the locations, there is only one location of the man after the action, and it is at point C. Knowing the direction is essential information in describing motion. What are the directions that can be used in describing vectors? First is the wind direction. The north, the east, west, and south. We can also use human directions like up, down, left, right, forward, and backward. Angular directions are common, Particularly in physics, the sample is 25 degrees from the horizontal. The specific location can also describe a vector. An example is towards Manila City Hall. Stream flow is also used in describing vectors like the speed of boat, moving either upstream, downstream, or even across the stream. Often, angular and wind directions are combined, such as 30 degrees south of east. To obtain other quantities, scalar quantities can be combined. Scalars can be added, subtracted, multiplied, or divided. Only the same scalar quantity can be added or subtracted. The same or different scalar quantities can be multiplied or divided. But in any operations between two or more scalar quantities, the result is the same or another scalar quantity. Vector quantities can be added, subtracted, multiplied, and divided. Only vectors of the same kind can be added or subtracted. Two vectors can be multiplied or divided regardless of whether they are the same or different kinds. The product of two vectors in the same direction is a scalar quantity, while the product of two vectors perpendicular to each other is a vector quantity. However, you cannot just multiply or divide any two vector quantities. There should be an existing relationship between these variables. Vector quantities can be illustrated as an arrow. An arrow has different parts, and each element represents a characteristic of a vector quantity. An arrow has a tail, head, and length. The tail of the arrow represents the origin of the vector. The head shows the direction of the vector, and the length of the arrow denotes the magnitude of the vector. Thus, a longer arrow means greater magnitude. This observation is correct if the vectors are drawn using the same scale. The scale is the ratio between the illustrated vector and the actual or real vector. Let's have an example. A man walked 150 meters 30 degrees north of east. This vector quantity is displacement. Let's call it vector A. So vector A is equal to 150 meters 30 degrees north of east. A is equal to 150 meters. This measures the magnitude of vector A. Theta sub A is equal to 30 degrees north of east. This angle is the direction of vector A. Thinking of a short band paper as the illustrating paper, 1 centimeter to 15 meters could be an appropriate scale. The next thing to do is to convert the actual vector to an illustrated vector using the preferred scale. Similar to converting measures from one unit to another, the illustrated vector has a magnitude of 10 centimeters. The direction remains the same. Plotting a vector quantity. The illustrated vector can be drawn graphically on a drawing paper. The illustrated vector 10 centimeters, 30 degrees north of east. The vector's magnitude is 10 centimeter and the direction is 10 degrees north of east. First is to draw the axis and locate the wind direction. Using protractor, measure and mark the location of the direction of the vector. From the origin, draw a line passing through the mark. Using a ruler, measure the length of the illustrated vector, 10 centimeters. To facilitate viewing of the measure, mark every centimeter measure on the illustration of the vector. Draw an arrowhead on the last mark, the 10 centimeter mark. The picture shown is the plot or the image of vector A. Let's have another example. Vector B is equal to 240 meters, 120 degrees. Plot this vector using the scale 1 centimeter is to 20 meters. Convert the actual measure of the vector using the prepared scale. After the conversion process, the illustrated vector B is 12 centimeters, 120 degrees. The magnitude is 12 centimeter and the direction is 120 degrees. After measuring the directions and magnitudes of the vectors, this is the illustrated vector. Resultant vector is the sum of two or more vectors. It is a single vector which is equal to the sum or the combination of two or more vectors. Resultant vector can be obtained using graphical solution. That includes Parallelogram Method and Polygon Method. The second solution to obtain the resultant vector is analytical. In the resultant vector, that vector R can be determined using the triangle method and the component method. The magnitude of the resultant vector is R, and the direction of the resultant vector is theta sub R. Now let's proceed to the parallelogram method, which is the first graphical solution. This method is also known as tail-to-tail method. Let's have this problem in presenting this method. Find the resultant of vectors A and B with actual measures. Vector A equals 240 meters, 120 degrees, and vector B equals 200 meters, 30 degrees. These vectors are in its actual measure. The first step is to convert the actual vector to illustrated vector. So with the given vectors, A equals 240 meters, 120 degrees, and vector B is 200 meters, 30 degrees. The required in the problem are R, the magnitude of vector R, theta sub R, the direction of vector R, and vector R. The conversion of the vector from actual to illustrated measure requires an appropriate scale. The appropriate scale could be 1 centimeter is to 20 meters. The magnitude of vector A is equal to 240 meters times the scale as a ratio of 1 centimeter and 20 meters. The unit meter cancels out, and the magnitude of the illustrated measure of the vector A is 12 centimeter. The magnitude of vector B is equal to 200 meters times the scale as a ratio of 1 centimeter and 20 meters. The unit meter cancels out, and the magnitude of illustrated vector B is 10 centimeters. The magnitudes of vectors A and B are 12 centimeter and 10 centimeter respectively. The direction of these vectors remains the same. The next step is to plot the vectors from the same axis, or the tails of the vectors are plotted from the same point. Measure and plot the direction. A vector equation will guide you in plotting the vector. Vector R equals vector A plus vector B. Draw the x and y axes. Using a protractor positioned at the origin of x and y axis, mark the direction of vector A and draw a line passing through the mark. Measure also the direction and of vector B and draw a line passing through that mark. Using a ruler, measure and mark every centimeter measure of vector A. Draw an arrow. With the ruler, measure the length of vector B, mark every centimeter, and draw an arrow. This is the plot of vectors A and B. The next step is to complete the parallelogram. Draw a line parallel to vector B from the tip of vector A. To make sure that the line is parallel to vector B, using a protractor, measure the same angle as the direction of vector B from the tip of vector A. Draw a line parallel to vector A from the tip of vector B. Using a protractor, measure the same direction as vector A. These two lines complete the parallelogram. Draw a diagonal from the origin to the opposite corner and fix an arrow. This arrow is the resultant vector. So the diagonal of the parallelogram formed by vectors A and B is the resultant vector. Measure the magnitude of the resultant using a ruler and the direction using a protractor. Using the ruler, the resultant R is 15.6 centimeters. And using the protractor, the direction is 80.2 degrees. These measures are the measures of illustrated vector. So inasmuch that the resultant vector lies on the first quadrant of the x and y axis, the direction of the resultant is equal to the measured angle. Determine the actual measure of the resultant vector. Using the same scale, convert the illustrated vector to actual vector. The magnitude R, which is 15.6 times the ratio, the scale 20 meters divided by 1 centimeter, cancel centimeters. The actual magnitude of the vector is 312 meters. Thus, vector R is 312 meters, 80.2 degrees. State the resultant vector completely. The magnitude of the resultant is 812 meters and the direction is 80.2 degrees. The final answers. The resultant vector is 312 meters, 80.2 degrees. Therefore, from this example, vector R equals vector A plus vector B, where vector A is 240 meters, 120 degrees, and vector B is 200 meters, 30 degrees. When added using the parallelogram method, the resultant is 312 meters, 80.2 degrees. Before we proceed to the next graphical method, I hope that the parallelogram method is already clear to you. If not, you may review or revisit this video. The next method is the Polygon Method, or otherwise known as the head-to-tail method. Now let's use the following forces in discussing the Polygon Method. Force sub 1 equals 600 newtons, 60 degrees. Force sub 2 equals 500 newtons, 180 degrees. Force sub 3 equals 800 newtons, 260 degrees. If these forces are acting on a single body, find the resultant force. The first step is to convert the actual measure of the vectors to illustrated measure. From the given forces, the required in this problem are F sub r, the magnitude of the resultant force, theta sub r, the direction of the resultant force, and vector F sub r, the resultant. The conversion from actual measure to illustrated measure, a scale is needed. And the appropriate scale could be 1 centimeter is to 100 newtons. So following the same method in converting measures, similar to what we did in the parallelogram method, the illustrated vectors have magnitude of, for 4 sub 1, 6 centimeters, 4 sub 2, 5 centimeters, 4 sub 3, 8 centimeters. The magnitudes and directions of the illustrated forces are 6 centimeters for F sub 1, 5 centimeters for force sub 2, 8 centimeters for force sub 3. The directions of the forces remains the same. The next step is to draw the axis and plot the first vector from the origin. So guided by the magnitudes and directions of the illustrated forces and the vector equation, F sub r equals F sub 1 plus F sub 2 plus F sub 3. Draw the axis, measure the direction of the first vector using the protractor, draw a line for the first vector. Measure the length of the vector using a ruler, show the centimeter marks, and draw an arrow. Draw a secondary axis at the tip of the first vector and plot the direction and magnitude of the second vector. Draw a secondary axis at the tip of the second vector. Plot the direction of the third vector. Draw a line. On this line, measure the length of the third vector. Should there be fourth vector or more, continue the process until all the vectors are plotted. This method is Polygon Method because the resulting figure must be a polygon. By definition, polygon is a closed figure. So, draw a line that will close the polygon from the origin of the primary axis to the tip of the last vector. This line will close the polygon. This closing side of the polygon is the resultant vector. Measure the length of the resultant vector using a ruler, and in doing so, the length of the resultant vector is 4.2 centimeters. Measure the direction of the closing side of the polygon, which is the resultant vector, using a protractor. And the measured direction is 39 degrees. Inasmuch as the resultant force acts on the third quadrant of the primary axis, the direction is the measured direction plus 180 degrees. So the direction of the resultant vector is 219 degrees. These measures are measures of the illustrated resultant force. Convert the magnitude of the resultant to its actual measure using the same scale. The magnitude of the resultant force, 4.2 centimeters times the ratio 100 newtons is to 1 centimeter. The centimeter units cancels out. The result is 420 newtons. The resultant force is equal to 420 newtons to 119 degrees. Therefore, the resultant force, which is equal to F sub 1 plus F sub 2 plus F sub 3, where F sub 1 is 600 newtons 60 degrees, plus 500 newtons 180 degrees, plus 800 newtons 260 degrees. The resultant force is 420 newtons 219 degrees. Now we're done with the graphical solution. Let's test your understanding by solving these problems. The first problem is, a man walked 125 meters north and 250 meters 80 degrees south of east. Determine the resulting displacement of the man using parallelogram method. So use the scale 1 centimeter is to 25 meters. The figure will help you visualize the problem. The second problem is to be solved using Polygon Method. The forces shown in the figure are acting on a single body resting on a frictionless surface. What single force may replace these forces? With a scale of 1 centimeters to 5 newtons, follow the vector equation. Vector R equals vector A plus vector B plus vector C plus vector D. In this problem, show your solutions to these problems using separate sheets of short band papers, and have your instructor or professor check your answers. That's all for this topic. Hope you meet the objectives of this lesson. Thank you for watching this video. And don't forget to like, share, and subscribe for more learning videos. Thanks and good luck.